Hi everyone, it's Coach Fred here, and as we get into this unit on special types of factoring that are a little bit higher level than what you're used to, I wanted to go over numbers 11 and 12, so this video is going to be a little bit longer. So we just talked about the fact that sometimes factoring doesn't look the way we're used to, and that especially when we're dealing with polynomials of higher degree, that we have to be really careful, and we do have to follow a process. So this particular example says factor. And what I have to notice is it's a degree 3. So if it's a degree 3, you immediately jump to the sum and difference of cubes. But the sum and difference of cubes would be 2 terms. And this clearly has 3 terms, so it's a trinomial. So then I start to look for some of the special little things that I've said we could look for. And earlier this year, I introduced you to the idea of U substitution. Now, I also assigned a video that comes after these pages on U substitution, but at this point, we have used it. So this was a place where I noticed, and again, noticing and wondering is really helpful. I noticed that both of these terms had an x minus 1 in it, and I also noticed it was a trinomial. So in my mind, I was like, gosh, I wish that wasn't x minus 1. I wish it was just x. So that's when I say to myself, oh, maybe U substitution can help me. So I'm going to use it. I'm going to let U equal x minus 1. Now, you could let it be any variable. The old-fashioned way I learned it was that we let it be U. And U substitution is used in calculus, pre-calculus, and it can be really used to make questions or expressions, equations simpler until the end. All right, so if I replace that, I now have something that looks a little bit better. Okay, so I go through my factoring process. There's no GCF. I count the terms. It's a trinomial. So if it's a trinomial, I'm going to look for a perfect square trinomial, but it's not quadratic. Okay, so that means that this might be the case where I actually can't factor it the way I'd like to. Now, until we learn division, I wanted you to get creative. And so I said, okay, in these examples, maybe the calc could help us. So if I put this into my calculator, it's a cubic function. You're going to see that it has one factor, or one x-intercept. And that x-intercept, when I looked at the calculator, was 4. Okay, so that means that an x-intercept was 4, which means that a factor was U minus 4. So I'm going to work backwards. I'm going to make an area model for myself. Now that factor is really important because that factor times something else has to equal U cubed minus 15U minus 4. All right, and that's what we did in class just the other day. All right, so I'm going to label this side U minus 4, but it really doesn't have to go there. It could have gone across the top and you could have gone 3 down. I just like it like this. All right, so I know that inside all of these boxes, I'm finding their area. And when I add up all the areas, it needs to equal this. All right, so I know that in my first box, I'm going to get a U cubed because that would be where my first term came from. And my last term would come from typically this box. So I'm going to put that there. So I'm going to use that idea to kind of help me get through this. I know that everything else has to give me 15U. No U squared. All right, so let's see what happens. I'm going to get a U times what would give me U cubed. So that's going to give me U squared. And then I can use the U squared and the negative 4 to say this is negative 4U squared. But my polynomial doesn't have any U squareds in it. So I know that I have to be able to cancel it out. So that would give me 4U squared would have to go here. Those would then simplify to 0 because they're opposites. They're additive inverses of each other. Okay, this box gave me negative 4, which told me a 1 would have had to go there. That tells me that this box here would have to be U. All right, I need a 15U. Well, I have a positive 1U, so the only way for me to get a negative 15U would be if this was negative 16U. Because then these two together would then add to negative 15U. All right, so that means that in this box right here, I'd have 4U. And so there is my other factor. U minus 4, U squared plus 4U plus 1. And we know that would equal u cubed minus 15u minus 4. Now, we are going to learn how to do this using division, but we haven't yet. So this is a creative way to think about it. All right, so what did we have to do? We really needed to find at least one x-intercept. So you wouldn't be able to do this if you didn't know that. So the calculator or Desmos could certainly help you here. All right, now we're not finished though, because now we've got to go back to where we started. We have to substitute in x minus 1. So I'm going to take this, x minus 1 minus 4, x minus 1 squared plus 4 times x minus 1 plus 1. And then I'm going to simplify it. So x minus 5. Now here I want to be really careful. You can't distribute a 2 over addition and subtraction. So you'd want to multiply that binomial out, which I expect at this point you can do. Distribute your 4. And then simplify. So that's going to give me x minus 5 times, let's see, x squared plus 2x minus 2. And there, I am done, and I've factored it. All right, so now every factoring problem, we're going to kind of have to think really critically. On this next one, oops, the one at the bottom of this page, this next one, it says subtract. Maybe that was the confusing part. You really don't want to distribute here. You want to take a second and think about our grouping symbols and what's going on within them, right? GEMDAS, it's an expression. I always follow GEMDAS. And no, I can't distribute the 3 in the first polynomial of x minus 4, but this actually stood out to me, this x cubed and 4 cubed. If I had written that as x cubed plus 64, would you have noticed it as the difference of cubes, or the sum of cubes, sorry. So I decided I was going to simplify that piece first. Okay, so x plus 4 cubed minus, what would that be? Well, that would be x plus 4 times x squared minus 4x plus 16. So the sum of cubes. All right, now, if you look back, now this is a place where it's like the second step of grouping where I see a common factor that actually is an expression. So that common factor can actually get pulled out. Remember, when we are looking at grouping, we want to look for those ones that might have perfect square trinomials or dots in them. So if I pull out x plus 4, I would be left with, if I pulled an x plus 4 out of x cubed, I'd be left with x plus 4 squared minus x squared minus 4x plus 16. Look at that. All right, now I'm going to simplify. So here's where I'm going to be subtracting. I'm going to restate that square of a binomial as a perfect square trinomial. I'm going to subtract. I'm going to distribute my negative here. I'm going to simplify, continue to simplify here. Those cancel, and then 8 and 4x gives me 12x. And there would be my factored form of a polynomial. All right, hopefully that was helpful. That was number 11 and 12 on page 8 of your Special Types of Factoring Introduction to Unit 3. Have a great day.